Chapter 2 video for chemistry. This is Claire Malberg. For question 1 was to draw the pair of molecules and explain the definition. And question 1 was to draw the pair of structural isomers. And my definition for structural isomers is that this is a compound with the same molecular formula, but the connectivity of the atoms are different. So as you can see, they both have 6 carbons, but they do not look the same. And they have the same molecular formula. Question 2 was the same, to draw a pair of molecules and explain the definition. This was for conformational isomers. The definition is that they are different by 1 or more bonds, but still have the same connectivity and the same molecular formula. This one, you kind of have to imagine that they are different. I tried drawing the 3D figure, but it was just not working out. And so if you search up a 3D figure, you would be able to spot the difference a lot better. They do just look the same on paper. Question 1C was, again, to draw a pair of molecules and explain the definition. So this is for a pair of cis-trans isomers, and the definition is that the substituents position differ on a double bond or ring. The cis isomer are on the same face of the ring, while the trans isomer are on the opposite. So I tried to draw it for the cis isomer. It's on the bottom side. The trans, it's on the top. Like, I did draw some arrows bottom and top, so you can see. And then question 1D was to draw the pair of molecules and explain the definition. So this was for a pair of enantiomers, kind of hard to say. And the definition is that this compound contains at least one chiral center, and they are non-super impossible mirror images. And so this one, you can see the hydrogen is flipped on this side, as in a mirror would be. These two just stay the same in the order, and then these two are what gets flipped to look like a mirror on that. The next part of the assignment was to write an example balanced chemical equation showing the reactant and product structures and explain how you classified each of your chemical equations using the definition of each reactant type. The first one was for a synthesis reaction. In this reaction, the reactants combine to form one product. So as you can tell, these two reactants are forming one product. And this one is just that simple substances combine to form something a lot more complex. Next up was a decomposition reaction. This is where one large reactant turns into smaller substances. So typically 2 or more. Because you can see it starts off with one larger reactant and that gets turned into 2 smaller substances. It is like the opposite of the synthesis reaction on this one, where it goes from 2 to 1 to 1 to 2. Next up was the hydrolysis reaction, and the definition is that it is a breaking of one large organic molecule into 2 smaller molecules, as well as the transfer of electrons between 2 substances. So you can see the hydrogens and the right side of it for the example. The next one was a oxidation reduction reaction. This is where non-metal atoms gain electrons while metal atoms lose electrons. So you can see this is the oxidation on this side, losing the electrons when it gets over here. And then this is the reduction, gaining the electrons. I tried to draw an arrow. It gets kind of confusing, but oxidation is over here, and the reduction is right there. next up is the hydration reaction. This is a reaction where the hydrogen and reactions where they get added to the carbons in a carbon-carbon bond or double bond. I messed that up. Got confused, but yeah. It's the hydration reaction. This is a 5 down here. And then question 3 was to answer a couple of questions about maltose. And so the first part of the question is, how is maltose commonly produced? And then what is it used for? So I found that maltose is the breakdown of starch, where grains get malted to produce maltose, and then high levels of maltose are found in barley. And then also they can be found as a key ingredient in beef. Next part to that question was to draw the structure of maltose. So here is the structure. And then the next part was to label the glycosidic bond and then name the bond. And so the oxygen is the glycosidic bond in the middle, and then there is the name. I just put those on one card. And then lastly, it was to draw a chemical equation for the hydrolysis of maltose to form 2 monosaccharides, showing structures of all reactants and products. And yeah, here's my chemical equation. We kind of ran out of room on this side, so I'll just get a little bit closer. And that is my video for chapter 2.